Hi everyone, in this video lesson we're going to use long division to divide polynomials. So I'm going to give you a transition into that by using just numbers. Okay, so here we just think, okay, how many times does 3 go into 7? 3 goes into 7 2 times, right? And then multiply 2 times 3, which is 6. Then subtract that 6 from the 7. That gives you a remainder of 1. Then drop that 4, which is the next one that we divide by, so 14. Think about how many times does 3 go into 14. 3 goes into 14 4 times. Now multiply 4 times 3, that gives us 12, and then subtract that 12 from 14, that gives us a 2. Now drop that 6, and now we're thinking about, okay, how many times does 3 go into 26? 3 goes into 26 evenly 8 times. Then multiply 8 times 3, which is 24, and then subtract that from 26, so we have a remainder of 2. So then our final answer is 746 divided by 3 is 248 with a remainder of 2 over 3, or 2/3. Okay, so we call this part here the remainder. And this one here is called the quotient. Okay, so this is the quotient, and this one is the divisor. Okay, that's a divisor, and this one here is the dividend. And I know you have not seen this in a while, so there you go. That's for long division. So let's apply that idea into the next examples. So for example number 1, state if the divisor is a factor of the given polynomial. So the answer is going to be yes or no, and then I'm going to, if it is a factor, then I'm going to make a statement. So for this one here, what you do is you take the first term, which is x squared. You can do this mentally, but I'm just doing this so that you can see how this works. X squared divided by x is x, so then that x goes here. Now think, if I multiply x times x, that gives me x squared, and x times 4, that gives me 4x. But just like long division with numbers, you subtract. So then this becomes minus, and this becomes minus. Okay. Then x squared minus x squared, they cancel. 9x minus 4x, that's 5x. Now I'm going to drop the 20 here, so plus 20. And now we're dividing 5x by x. So when you divide 5x by x, that gives you a 5. So that 5 is positive, and it goes here. Now think again, you're multiplying 5 times x, that's 5x. 5 times 4, that's a 20, and it's positive. Then I'm going to subtract the 5x and also the 20. So then that means the 5x is canceled and the 20 is canceled, so I have a remainder of 0. Okay, so the answer to this question is yes, but then I need to make a statement here. Okay, and the statement is, therefore, since we have a remainder of 0, we say that x plus 4 is a factor of x squared plus 9x plus 20, because we have no remainder. Okay, and let me just say that here. I'm going to write that here. This means therefore in math. So those 3 dots means therefore. So this is my answer along with this. Okay, so yes, it is a factor, and then just make that statement. So that's example number 1. Example number 2, same thing. You start by taking the first term here, the lead term, which is the square, divide that by x, and that gives you x. So then that x goes on top of the 7 x's. Now we're multiplying x times x is x squared. X times negative 5, that's minus 5x. But then don't forget, we subtract. So this changes to minus. This one has a negative in front of it, so then it changes to plus. So now the x squares cancel. So we have negative 7x plus 5x. That's negative 2x. And then pull down that 13. Now we are moving on to dividing the negative 2x by x. So then negative 2x divided by x is equal to negative 2. So then that 2 goes on top of the negative 13. Okay, so this is minus 2. Now multiply again. Negative 2 times x, that's negative 2x. Negative 2 times negative 5, that's positive 10. So then let's subtract. So this changes to plus, this changes to minus. So then we have that the 2x's cancel, but 13 minus 10 is 3. So we have a remainder. Okay, so the answer to this one is plus, we have a remainder of 3 over x minus 5. So this is the answer. And for this one, I'm just going to say that it is not a factor. So no, not a factor. Okay, so I don't need to make, I'm not going to make the statement that I made here. I'm just going to say that it's not a factor because there's a remainder. So let's go on to example number 3. And for example number 3, notice that I had to rearrange these terms because this is, you always, the highest exponent goes first and then it goes in descending order. Okay, so now I'm dividing this term, which is 3x to the 4th. So 3x to the 4th, I'm going to the margin, divide that by 3x, and that is equal to x to the 3rd. So then that goes here, x to the 3rd. Now you're multiplying again. X to the 3rd times 3x, that's 3x to the 4th, and then x to the 3rd times negative 2, that's negative 2x to the 3rd, or 2x cubed. Okay, now we change the sign, so this becomes minus, subtracting this becomes plus. So then these cancel. So now we have negative 5x to the 3rd plus 2x to the 3rd, that's negative 3x to the 3rd. And then we pull down 2x, right? So then 2x squared, so plus 2x squared. And now let's take this term. So we have negative 3x cubed divided by 3x. And that gives us negative x squared. So then that goes on top of the 2x squared, so minus x squared. Now multiply again. So negative x squared times 3x, that's negative 3x cubed. And then negative x squared times negative 2, that's plus 2x squared. But now subtract. Okay, so then this changes to plus and this one changes to minus. So these cancel. So we have 2x squared minus 2x squared. We have 0x squared, right? So then I'm going to pull down 3x minus 2. And now let's divide again. So we have 3x divided by 3x. That gives you 1. So then that goes here, plus 1. So then when I multiply 1 times 3x, that's 3x. And I'm already saying minus because I know I'm going to subtract. 1 times negative 2, that's a negative 2, but then I'm going to subtract, which means this changes to positive 2. So in the end, everything cancels, so we have 0 remainder, okay? Therefore, so I'm going to say therefore, 3x minus 2 is a factor of 3x to the 4th minus 5x to the 3rd plus 2x squared plus 3x minus 2. Okay, so there's my statement saying that it is a factor. Okay, so I have 2 more examples to go over. And notice that I'm saying here, we have x to the 3rd, x to the 2nd, but there's no x to the 1st. Okay, so when you divide using long division, always have a placeholder for that missing power. In this case, x to the 1st is, we don't have one, so just write that down because you'll need it sometimes to be able to do long division. All right, so then again, I'm dividing x to the 3rd. So this is the scratch work, divide that by x, that is equal to x squared. So then that x squared goes here. Now multiplying x squared times x, that's x, x to the 3rd, right? And then I'm multiplying x squared times negative 1, that's minus x squared or minus 1x squared. But then I'm going to subtract, which means this changes to minus, and this is minus, so changes to plus. So then the x to the 3rd cancels, and negative 3x squared plus x squared is equal to negative 2x squared, right? So negative 2x squared. Now let's take this term, so negative 2x squared, divide that by x, so that gives us a negative 2x. So then that goes on top of the 0x. See, this is why we need a placeholder. So minus 2x here, and now multiply. Negative 2x times x, that's negative 2x and I forgot to pull this here, so plus 0x, okay? So negative 2x squared, and then negative 2x times negative 1, that's positive 2x. Now, as you can see, we're going to subtract, so this changes to plus, and this changes to minus. So then these cancel, and now we have negative 2x as a lead coefficient. So now drop the 1, so plus 1, and then divide negative 2x by x, and that gives us negative 2. So this is minus 2. And now multiply again. So negative 2 times x, that's negative 2x. Negative 2 times negative 1, that's positive 2. But then change this to, we're going to change the sign. This becomes plus, and this changes to minus. So then these cancel. Now we have a negative 1 as a remainder, which means we have minus 1 over x minus 1. That is a remainder. So the answer to this one is that it is not a factor. Okay, this is the answer. I'm going to box it in, and then it is not a factor to that of that polynomial. Okay, last example. So for this example here, notice again I have two placeholders. I don't have x to the third nor x to the first. Okay, so don't forget to write those down. So then let's take the first term, which is x to the fourth, divide that by x to the second, and that is equal to x squared. So then that goes here, x squared. Now multiply x to the second times x to the second is x to the fourth. X to the second times 1, that's 1, or just x squared. But then we're going to subtract, so this changes to minus, and this changes to minus. Okay, so we won't need this one here. So let's cross it out. So then these cancel, and we have now 3x squared, because 4x squared minus 1x squared is 3x squared. Now let's pull down the 0x, and I'm going to pull this down to plus 3. Now divide 3x squared by x squared. Okay, so then this gives us a 3, so that 3 goes here. So now we multiply 3 times x squared, it's going to be 3x squared, and 3 times 1 is 3. But then again we subtract, so this becomes minus and this becomes minus. So then these cancel and the 3's cancel, so we have a 0 remainder, which means that I can make that statement that says, therefore, okay, therefore x squared plus 1 is a factor of x to the fourth plus 4x squared plus 3. Okay, and we are done with this lesson. I'll see you in the next one. Bye-bye.